I'm going to go ahead and work through a projectile problem that is similar to a projectile being launched into the air, and that is going to be similar to 4.4 in our book, section 4.4, problem number 11. So let's take a look here. We're given a function, and let me just read through what this function represents. So a projectile, some kind of object, is launched from a cliff that is 220 feet above the water, and it's not being launched straight up. It's at a 45-degree angle. So there's going to be a distance away from the cliff as well as a height having to do with the relationship between x and h of x. We're going to have to read what x represents, if this is the height or if this is the distance away from the cliff. And I think it says it here in the next sentence. It says the height h of the projectile above the water is given by this, where x is the horizontal distance of the projectile from the face of the cliff. So x, the input, is how far I am away from the cliff horizontally, as if I had this kind of situation here. This distance here, this is going to be x, right? And the height is going to go ahead and be the vertical distance above the cliff, right? H of x. Okay, so let's go ahead and try a few of these. So it says here, at what horizontal distance from the face of the cliff, this x distance here, would the projectile be by the time it reached its maximum height? So we really, again, are being asked for the x-coordinate of the vertex, right? So this object's going up like this, and what we're saying is when our height is maximum, how far are we away from the cliff, right? And that would be the x-coordinate of the vertex. So we're going to go ahead and say here, and I'll tell you what, our math is going to get, just more arithmetic, but it's going to get a little more involved in this problem than some of the problems we've done before. This is going to be x is equal to negative b over 2a, but did you notice this 2a has a fraction in it, and that's where we're going to get into actually complex fractions from our previous Math 95 class, and I know most of you have taken that class, not everyone, but let's go ahead and take a look. So we got here negative b would be negative 1, and I'm going to draw a long fraction bar so that I discern the difference between the main fraction that I have here representing negative b over 2a and the fraction that is 2a itself, because a is negative 32 over 50 squared, and 2a would be 2 times negative 32 over 50 squared. But that's just the denominator right here, right? So what this is now going to become is this. I'll have negative 1 over, and 2 times negative 32 would be negative 64 over 50 squared. And here's our main fraction. Well, we're going to borrow from an arithmetic move having to do with dividing by fractions. To divide by a fraction is to multiply by the reciprocal. And by the way, this is negative over negative is positive. But I'm now going to say to divide positive 1 by positive 64 over 50 squared is to multiply 1 by its reciprocal, right? Because division by a fraction is multiplication by the reciprocal. So I'm now going to say that my x-coordinate of my vertex is 50 squared over 64. Is 50 squared over 64. Now, I could go ahead and convert that into a decimal number of feet. Let's just go ahead and take a look here. And so I have 50 squared divided by 64, and that turns out to be 39.0625. 39.0625 feet away from the edge of the cliff in a horizontal direction, right? Okay, and you know what, I just want to see if I could find the answer key here and double check if they're leaving these in exact answers or if they are going to a decimal. Let me see if I can find that. It looks like they did go ahead and they gave it in an exact answer. I don't think I'm super concerned about that, but it turned out if you take this 50 times 50, that's 2,500 over 64, and that would go ahead and reduce to 625 over 16. And that's what they gave as an optional answer here. And I just wanted to do that because I know when you go to do your homework and you look in the back of the book or you look up our answer key that I provided on Canvas, you're going to go ahead and see a fractional answer like that. But I would accept this here. It is nice to know how to get an exact answer going through the work that we did here, though. Okay, let's go to the next question. It looks like they gave a fractional exact answer to that also. Don't forget, this is just a decimal approximation. That's the exact answer, although it would be kind of unusual to talk about that many feet, in a fractional form like that. Okay, so the next one is find the maximum height. Well, we already found the x-coordinate of the vertex. That was this right here. So to find the maximum height, we're going to go ahead and plug that x-coordinate into the function. I'll tell you what I would expect you to do in the homework is this. Go ahead and set it up so that I could see that you know what you're doing. And what I'm doing is I'm finding h of this value, right? I'm evaluating the function at that value. So here's my function. So I would like to see you set it up, but we could actually go ahead and use the calculator to go ahead and solve it. And so I'd have this. And then plus x, and so our x is 39.0625, and then plus 220. And we're going to really be working this out right here to go ahead and determine what the maximum height was, right? So we'll go ahead and get our calculator out. And I think this is a good opportunity to go ahead and remind you of the fraction feature on this calculator or on most graphing calculators. And so I'm going to go ahead and do this. I'm going to, in order to input this fraction right here, I'm going to go ahead and go alpha y equals, and I'll pick that first menu item there, and there's a fraction, and I'll put in negative 32, and then I'm going to multiply that by 39.0625, and that quantity squared. And then the denominator is going to be 50 squared. Okay, now don't forget, I have to escape this fraction to begin to add these other two terms. So I'm going to go over here. I right arrowed on my calculator. And now I'm going to go ahead and say plus 39.0625 and then plus 220. And there's my answer. We were at a height of about 239.53 feet. Okay. All right, so let's go ahead and see. We got two more questions here. The next one says, at what horizontal distance from the face of the cliff would the projectile strike the water? And I think what they're really saying then is our height would be 0. In other words, we'd be coming up and back down to the point where we were below the cliff, and I think this cliff was 220 feet, so we were actually down here, right? So we're looking for what would the x value be, this distance, when h of x is 0. Not x, but h of x, the height, is 0. So we'd really just be setting this function now equal to 0 and solving this right here. right? We're going to go ahead and solve that quadratic equation set equal to 0. Well, probably the best thing we could do is go ahead and use the quadratic formula here. I mean, that's a fairly complicated situation. And so what we're going to go ahead and do is, I think I'll take a separate piece of paper here and let's set this up. All right, so it looks like I have negative b, right, in our quadratic formula. Negative b is going to be negative 1 plus or minus the square root of b squared, which is going to be 1 squared, minus 4 times a, which is going to be this negative 32 over 50 squared, negative 32 over 50 squared, and times c, which is going to be 220. And then that's all going to be over 2a, which is going to be 2 times negative 32 over 50 squared. Now that's a lot to put in the calculator. I think what I'm going to go ahead and do is I think I'll just work this radical out, okay, and then I'll work the 2a out, and then we'll go ahead and come up with the solutions. Let's take a look here. So what am I taking the square root of? Let's just take a look. In fact, I'll tell you what, I think we'll just go ahead and get that answer. Let's put that all under a radical here on our calculator. All right, so let's see if I can get this to show both the calculator and my original work. I think that might be all right. I'm trying to avoid the glare here. Okay, so I have, I'm first going to go ahead and take the square root, so second square root, which is right above the x squared, and I'm going to go with 1 squared, and then it's minus 4, and then when I see that I have to multiply by a fraction, I think I'm going to go to that fraction feature again and hit alpha y equals, pick out the fraction button, and oops, my 4 ended up in the numerator. I'm going to have to delete that. I should have done 4 times, so 4 times, and then I'll hit alpha y equals and get my fraction, and then it's going to be a negative 32 in the numerator and a 50 squared in the denominator, and then I'm going to go ahead and go times 220, and that answer is about 3.5. So what I have now is this. So far I have negative 1 plus or minus, and the square root on the top turned out to be 3.5. Now let's figure out this denominator, okay, right? So the denominator says that it is, again, we've got a fraction, 2 times, and alpha y equals, and I'm after this right here, and I'm going to do negative 32 on the top and 50 squared on the bottom. And that turns out to be a negative 0.0256. Negative 0.0256. Now don't forget, what we're after here is the distance away from the cliff when the projectile hits the water. And so I know that's going to be a positive value. I'm going to think this through here a little bit. Negative 1 plus 3.5, that's a positive 2.5. Over a negative would give me a negative answer. I'm not even going to worry about that one. I'm just going to do the negative 1 minus 3.5, because that's the one that would give me a negative on the top and a negative on the bottom, producing an overall positive distance away from the cliff. So let's go ahead and put this in our calculator right here. Okay, so when we do that, we're going to get, and again, I think I'll use my fraction feature here. And I have negative 1 minus 3.5, and now I have to skip down to the bottom, and I'm going to do negative 0.0256, and I get, it would be 175.78 feet away from the cliff at the point where I went, and I could round that off. I don't know if it said to the nearest foot or not, but that would be the distance away from the cliff when the projectile hit the water, and that is this answer right here. (175.78 feet). Okay, so what happened originally, and let me just show you the rest of the work here, is to get this answer right here, the distance away from the cliff where it hit the water, we let the height be 0. We had a quadratic equation. I went and solved that quadratic equation right here, and I got this answer of 175.78 feet away. Okay, there is one more question, and it has to do with using the graphing utility to go ahead and graph this. It says, which of the following would show the graph of the relationship between the distance away from the cliff and the height as the projectile went through its trajectory, right? So I did preset this up. It says they give me a window here that it wants me to set my calculator to. They want the X window to be from 0 to 190, and the window for the Y coordinates to be from 0 to 260, and they're going to jump by 20 units on the X scale and 50 units on the Y scale. And so I went and did that already. Let me show you what I have here. So I put in the original function, and remember, we got that right here at the top. You can see I have that function right here in my calculator. And then you can see in my window, I also, right here, tried to set this window to what the parameters were in the problem. And it says here, for example, the X minimum and maximum were from 0 to 190, and the scale was 20. And then the Y was from 0 to 260, and the scale was in 50 units per tick mark, right? So let's see what kind of graph I got, and you might try this yourself. And now we're going to go ahead and compare it here and pick which option it looks like it was, and let's just take a look here. It looks like, here are my choices. It looks like it's probably, let's see, this goes up what, 1, 2, 3, 4 units, right? And this went up 1, 2, 3, 4. It looks like a little above that. How many did this go out? Let's see. This went out. Don't forget, this is skipping in sets of 50 this way and in sets of 20 this way. I guess that'd probably be a better way to really check this out. We could go ahead, and we knew that when it hit the water, it was about 176 feet. So let's just go ahead and see here. This would be what? 20, 40, 60, 80, 100, 120, 140, 160, and close to 180. That seems to make sense. And I bet C is going to be the option. I mean, if we counted the rest of these off, we're not going to get that. And I won't take the time to do them all, but let me just do B as an example. 20, 40, 60, 80, 100, 120, 140, 160. It landed right on 180, not short of 180. And there'd be other ways we could go ahead and determine that, but it turned out that this is the graph that I got out of my graphing calculator.